Alright, here in this video I'm going to walk through the fundamental theorem of algebra, and we're going to look at how that theorem gets applied to solving or finding polynomial functions of higher degrees. So essentially your fundamental theorem or your polynomial would be in its factored form, and it looks something like this, where a(n), this term right here, would be similar to a leading coefficient. And then you have the x term, and these c values would be like your factor terms. Okay. So depending on what the power of your equation is going to depend on how many of these factor terms that you actually have. Okay. Now, one of the things that we need to keep in mind is that we have different types of zeros. We have real coefficients, we have complex, and we have rational coefficients. Okay, so you kind of have to look at your polynomial as you go to see what's going on with it. So the easiest way to explain or work with the fundamental theorem of algebra is just to go ahead and work an example. So here what happens is you're usually given information about a polynomial. You're given maybe all or just a few of the zeros. You're told what the degree is going to be, and you are given either a y-intercept or a leading coefficient or both. Okay, and so here we're told that we have third degree. So in this case we know that n is equal to 3. We are also told that we have real coefficients, and when we look at our zeros, we have 5 plus I. Now the cool thing is whenever you have a complex term like 5 plus I, you also have to have the negative. So this means we also have 5 minus I, and then we're told you have negative 1. So these are your three zeros. So the first thing you need to do is rewrite your zeros into factors. So your factors would become x minus 5 minus I, x minus 5 minus or plus I, and x plus 1. Now once we do that, we have to look at the rest of what we have, and we have a y-intercept, so my b term is going to be 0, negative 52. So in order to figure it out, the first thing that we have to do is we have to take my factors here and we have to multiply all the factors together. So the easiest thing to do is to pick two of the factors that you want to work with and use them. So for example, we could use x minus 5 plus I and x minus 5 minus I. And we can do those so we can deal with the complex idea. And so to multiply them together is exactly as you would think. You're going to take your first and you're going to distribute it into your second. So here this is going to be x times x, which is going to give you x squared. Then you're going to have x times a negative 5, so minus 5x minus xi. Now the next thing that we have to do is we got to take the middle term, or the next one, and do the same thing. So we're going to do this one times all three pieces of that secondary factor. So here this is going to be minus 5x plus 25 plus 5i. And then the last thing we're going to do is take the I. So we're going to take this in to all three pieces. So we're going to have plus xi minus 5i minus I squared. So now with this, we have to combine our terms. So here, this is an x squared. I have a 5x, 5x. And so here we're going to go ahead and combine those, which is negative 10x. I have an xi and an xi, and notice those go away. So this is gone. We've got a 5i and a negative 5i, so these go away. And then we have to remember that this I squared piece here is going to be negative 1. So end up with plus 25 plus 1. So this is going to be x squared minus a 10x plus 26. And we're going to now multiply this by x plus 1. Okay. Now, when you multiply your two complex terms together, notice all the complex terms canceled. So if you find that once you combine your like terms you still have i's left over, chances are we've made a mistake somewhere, and that's your indication to stop and go back. Now in this case we're going to do the same thing we just did. We're going to take the x into your factor. So here this is going to end up being x cubed minus 10x squared plus 26x. And then we're going to take the 1 and we're going to bring this into the entire factor. So this is going to have plus x squared minus a 10x plus 26. So last we have x cubed. We've got this minus 10x and an x squared, so this is going to be minus 9x squared. I have a 26x and a 10x, so plus 16x plus 26. Now the other piece that we had to remember is that we had the b term. So here I also have to have my b term. So I'm going to subtract away the 52. So in doing that, that makes our final answer that our polynomial is going to be x cubed minus 9x squared plus 16x minus 26.
Dude, the gig is like next weekend. I know. I'm sorry. I really want to do this, but I can't usually get it.
Alright, let's do this one more time. In this case, I have a 5th degree, so n equals 5. And then we're told that 1 is a 0 of multiplicity 4. So when we're looking at our zeros, we would have x minus 1 to the 4th power, and then negative 2 is the only other 0, so then this would be x plus 2. Now the other way that we could do this is x minus 1 times x minus 1, x minus 1, x minus 1, x plus 2. We are also told your leading coefficient is equal to 4. So just like before, you would multiply all of this together. So we are going to take this polynomial and you are going to multiply all factors together. The easiest way to do that is to pick two of them and FOIL them together, and then to start distributing things through. Once you do that, you should come out with x to the 5th minus 2x to the 4th minus 2x cubed plus 8x squared minus 7x plus 2. Now the last thing, once you figure out your polynomial, is we need a leading coefficient here of 4. So in order to do that, that says I have to do a times my polynomial. So in this case, this is going to be 4 times my polynomial. So in this case, we're going to end up with 4x to the 5th minus 8x to the 4th minus 8x cubed plus 32x squared minus 28x plus 8.
Did I actually do it? I did. I did. The answer is 1 in 18 million. What is? The odds of you running into Mr. Watkins.
Alright, now with this one, we're giving the polynomials and you need to find the other zeros. So the easiest thing, or the fastest thing to do here, is to use synthetic. So we're given a 0, we're told the 0 is I. Okay, so before we get to I, since obviously we cannot pull an I out using synthetic division, there is one thing that we know. We know for a fact that if there's a negative I in terms of another 0, you have a positive I. So we're only missing 2 zeros out of this. So there's a few things that we can do. First, we can list our P's and Q's. So my P's in this case are going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. And my Q is plus or minus 1. So if we look at P over Q, that's what we have. And so essentially here, what you're going to do is you would use synthetic, but we would use synthetic more in like a guess and check. So I have 1, 5, 7, 5, 6. Now, this last term here ends in an even. So the first thing I would check is an even number to see if it works. So here we have 1, negative 5, 7, negative 5, and 6. Remember, synthetic, you're going to bring down that first term, and then you do bottom times the box goes underneath the next. So this is 2. We're going to vertically add, gives us a negative 3. Bottom times the box gives us a negative 6. When we vertically add, we get a 1. Bottom times the box is 2. When we add them together, we get negative 3. Bottom times the box is a negative 6. When we add them together, we get 0. Now, just like before, this is what we are looking for, and because of that, it says that we have a 0 at the point x minus 2. Now, the next thing I want to do is I need to find one more. So in this case, I'm going to start another box. And I have 1s and 3s. My 3s are all negative, so I'm going to try a positive. I'm going to drop down my term. 1 times the box is 3. Then we're going to vertically add, gives us 0. Bottom times the box is 0. Vertically add gives you 1. Bottom times the box is 3. Vertically add gives you a 0. So here we go. Again, we have a 0 as that last term. So this is x minus 3. So essentially what we have for our other zeros, so all other zeros are going to be 2, 3, and a positive I. Alright, so in this one, we are told that the 0 we have is a 2. Since that's the case, the first thing we would do is start with our synthetic. we would put our 2 in the box and put our equation. 1, 0, 0, negative 8. We would bring down the 1. Again, it's bottom times the box, and vertically add. 2 times 2 is 4. 4 times 2 is 8. Now, this right here should come out to be a 0. If this came out to be something else, then this 2 given would not be a 0. So always make sure that you are verifying your zeros when they are real. Now the other thing that we need to remember is that this started as an x cubed equation, but when it went through synthetic division, it became an x squared equation. So in this case, we actually have x squared plus 2x plus 4 equals 0. Now in this case, I would go ahead and I would use the quadratic formula. Remember that formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. And when you do that, you're going to find out that x is equal to negative 1 plus or minus the square root of 3. Therefore, we would say that all other zeros would be that x equals negative 1 plus the square root of 3 and x equals negative 1 minus the square root of 3. Now in this problem, you're asked to use any and all methods that you possibly can think of in order to try and factor. So a few such methods that would come to mind would be synthetic division, or you can use what's called U substitution, which U substitution is the idea where we're going to identify another variable. So we've already looked at the ideas behind synthetic division, so let's look at U substitution. U substitution says you have to make a statement, so we're going to say let U equal x squared. Then when we do that, if we take a look, notice this was x to the 6th, so what we end up getting is that f of u is going to be u cubed minus u squared minus 16u plus 16. Now once we do that, now we just simply have to solve this. Now this is a 4-term equation, so one way we can solve it is by grouping. Grouping says you're going to take your first 2 terms, you're going to look for what's in common between both terms and pull it out. So this would be a u squared. It's going to leave behind u minus 1. Now the goal is that in this back part, when you pull out its term, you get left behind the same as the first one. So here we came up with u minus 1, that's what we're hoping here. So we're going to pull out a negative 16 and get u minus 1. So the way that it works is you are going to write down the outer numbers. So here we're going to have u squared minus 16 times u minus 1. Now with that, we can keep going. This one right here is actually going to be u plus 4 times u minus 4 times u minus 1. Now here we have to remember that this was f of u, and what we want is f of x. So in order to do that, says now we have to undo your let statement. So in this case, if you remember, we said that u was x squared, so anywhere you have a u needs to become x squared. So in this case, my f of x is going to become x squared plus 4 times x squared minus 4 times x squared minus 1. Now, the last thing we have to do is recognize that we have two factors that can reduce further. So we have to reduce again. So here we're going to end up with x squared plus 4. Then we're going to have x plus 2 times x minus 2 times x plus 1 times x minus 1. Alright, the last thing that we can look at in terms of the fundamental is a quick review on being able to sketch graphs of polynomials. Again, if you remember, when you're sketching a graph, you need to keep the following in mind: end behavior, maximum number of zeros, the y-intercept, x-intercept, and min or max values. So let's go ahead and take a look. Here we have an x to the 4th problem. So first and foremost, when we're looking at this, there's a few things that we need to remember. If you have a multiplicity of odd, we are going to cross the axis. If we have a multiplicity which is even, then we are going to touch the axis. So first and foremost, let's look at end behavior. So here, if you look at it, you can see that my end behavior is going to be positive. And it's going to open up because my first term here is positive. My max zeros is going to be my degree, which is 4. My max terms is the number of zeros minus 1, which is 3. Now, the biggest hint I can give you here is that to find your zeros, use your graphing calculator. So you're going to use this to speed up the process by using the zeros function found in your calculator. So in this case, you would find out that my h of x is going to have x plus 1 times x minus 2
since we're sharing pictures, I have one different tribute. Please don't let it be you and your dog in the bathtub. It's not. But don't swipe.
Times x minus 3.
Oh, that's me and a beautiful.
Sorry, x squared minus 3. And so in this case, if we take a look at your zeros, this is going to occur at -1, 2, and plus or minus the square root of 3. So here, once we do that, we can actually start graphing. So we've got -1, we have 2, and then we have plus or minus the square root of 3. So right on the inside, or almost, not quite.
Sorry, he's a Kuta, you're not. Hi, hello. What you doing?
Now the other thing we can look at is the intercept of y. And we know here that my y-intercept is going to be 0, 6. And we get it because of this value right here, which is your y-intercept. So 1, 2, 3, 4, 5, 6. And of course, since we would have used our graphing calculator, we would know exactly how this is supposed to work or look. So we kind of get a little bit of a dip here. We get a little one here. So we're just kind of sketching the graph to the best of our ability, making sure that my end behavior is pointing in the direction it's supposed to, and that the zeros and the intercept have been graphed as well. Alright, so if you have any questions, please let me know. Otherwise, I do hope you enjoyed this video about the fundamental theorem of algebra, and I look forward to seeing you next time.